Three giants challenge the throne by forging their own weapons. But the Emperor strikes back. Build your own AI kingdom with Nvidia full-stack services.
For over a decade, if you wanted to build a business on the internet, you had to go through three massive gates: Google, Amazon, and Microsoft. These cloud service providers owned the infrastructure of the digital world. But when the generative AI boom hit, that dynamic flipped. Suddenly, the world's most powerful companies found themselves entirely dependent on a single hardware supplier to build their data centers. Buying hundreds of thousands of high-end GPUs requires massive capital. For the cloud giants, paying this steep hardware tax to a third party threatened to severely erode the highly profitable margins they had enjoyed for years. To escape this cost, the major cloud providers launched a rebellion. They began pouring billions of dollars into developing their own custom silicon, known as ASICs. An ASIC is an application-specific integrated circuit, which is a chip designed for one specific task, rather than general computing. Google built the TPU, Amazon created Trainium, and Microsoft designed Maya. The strategy was highly calculated. Move the computational workload away from third-party hardware and into their own proprietary chips. If developers built directly on Amazon or Google silicon, the standard GPU would become an easily replaceable commodity. Facing the threat of being engineered out, the dominant chipmaker had to respond. Simply manufacturing a faster processor wouldn't secure their position. They needed to engineer a system so tightly integrated that relying on alternative hardware would become practically impossible. To understand this counteroffensive, we have to look at the battlefield as a four-story building. This is the modern AI tech stack, divided into silicon at layer 1, data centers at layer 2, models at layer 3, and software frameworks at layer 4. The main selling point for those custom cloud chips was down here on the first floor. Legacy general-purpose GPUs face a physical bottleneck when handling the continuous tool calling required by autonomous AI agents. The problem is the memory architecture. High bandwidth memory, or HBM, is designed to move massive blocks of data for training. But when generating text serially, one token at a time, it suffers from latency and timing jitter. To solve this, the new Vera Rubin platform integrates specialized language processing units, or LPUs, based on technology from Grok. These LPUs use 500 megabytes of on-chip SRAM to deliver 150 terabytes per second of memory bandwidth directly to the compute elements. SRAM is a type of memory that is much faster and more reliable than the standard memory used in most chips. By pairing deterministic SRAM processors with their standard GPUs, Nvidia has closed the efficiency gap that previously allowed specialized cloud-native chips to compete on inference tasks. But the cloud providers still held the second floor. Historically, their strongest advantage was absolute control over the physical data centers. They owned the real estate, the cooling systems, and the power grids that enterprises relied on. Rather than building competing real estate, a new strategy emerged to bypass it entirely. The chipmaker began supplying massive fleets of pre-integrated, liquid-cooled server racks to independent Neoclouds, agile, AI-specific hosting companies. At the same time, they started selling plug-and-play sovereign servers directly to large corporations and governments. To repatriate their data, these organizations require high-density compute clusters they can control physically. Historically, building an on-premise AI factory was impractical due to the complex industrial chillers and networking required to manage the heat of modern chips. Nvidia addressed this bottleneck with the NT-Hex architecture, a factory-integrated plug-and-play server rack that arrives ready to deploy. The innovation is a closed two-phase liquid cooling loop built into the rack, isolating the thermal management from the facility. This allows the servers to operate on standard facility water at temperatures up to 45 degrees Celsius, removing the need for expensive cooling retrofits. These units scale into the Vera Rubin POD, a cluster of 40 racks that functions as a single logical unit, delivering 60 exaflops. By modularizing hyperscale infrastructure, Nvidia allows private entities to purchase their own independent cloud region. Securing the hardware and the servers was only the foundation. The most aggressive move in this strategy takes place at the very top of the stack, Layer 3, where the AI models set, and Layer 4, the application frameworks. Nvidia released Nemotron 3 Super, a 120 billion parameter model designed to prevent context explosion in multi-agent arrays. By training natively on NVFP4, Nemotron achieves higher inference throughput than open-source alternatives like Qwen or GPT-OSS. It also maintains a 91.75% retention rate across a 1 million token context window, allowing agents to process vast data stores without losing accuracy. The final barrier to private AI is security. Enterprises are unwilling to expose sensitive systems, like their internal financial records, to external cloud models. Nvidia addresses this with NemoClaw, a software stack that functions as an operating system for autonomous agents. NemoClaw features a privacy router that inspects every data query before it leaves the local network. The router scans for PII, or personally identifiable information, which includes sensitive data like names, addresses, or social security numbers. Sensitive data is stripped out and processed strictly on the local hardware. Routine requests are sent to an external API to save local compute. Partners like Palantir are using this stack to build custom tools for the defense and intelligence sectors. This has created a national security OS for organizations that cannot operate on a shared cloud. The NemoClaw stack incentivizes organizations to move their most valuable data to infrastructure that Nvidia exclusively controls. By adopting this highly optimized top-to-bottom tech stack, large software vendors create a direct pipeline from the silicon up to their end users. They no longer need to rely on the managed machine learning services offered by the legacy cloud providers. What started as a defense of a hardware monopoly has expanded into complete vertical integration. These 4 vertical layers lock into place to isolate traditional cloud providers. The Vera Rubin silicon neutralizes custom chips, the MGX racks move infrastructure on-premise, and the software frameworks lock in the application layer. This strategy has already secured $30 billion in revenue from sovereign AI deployments in a single year. Nations like France and Japan are investing in these localized AI factories to protect their cultural and data sovereignty. This transition shifts Nvidia away from cyclical chip sales toward a recurring defense contractor revenue model. By tightly tying the topmost software layer directly to the base silicon layer, the entire ecosystem is locked into place. This creates massive disintermediation. Application developers can entirely bypass the complex software environments that Amazon, Google, and Microsoft spent years building to retain their enterprise customers. And the financial incentives are hard to ignore. By cutting out the traditional cloud middleman, businesses avoid paying the double margin, the substantial markup that cloud providers traditionally add on top of the raw hardware costs. The long-standing era of the cloud-first internet is fading. In its place, a fully integrated, vertically sealed architecture is emerging as the central operating system for the entire artificial intelligence economy.